All right, so thank you very much. I'd like to introduce my dear friend Dave Campbell, who is the product unit manager for Yukon working in SQL. And Dave has agreed to come and cover part 2 of Metropolis, and this is stuff that he and I have talked about for years, so yes. It's kind of a joint effort. And so here's Dave. Thanks.
Thanks, Pat. So to start things off, set the stage, Pat and I, actually I've known Pat for 9 years. I got here at Microsoft 9 years ago, and we started off doing distributed transactions with SQL together initially. Then Pat and I have gone off and done a couple other things together, including, I don't know if we talked about it in the previous talk, the service broker for SQL Server. Spent some time thinking through some of the issues on WinFS as well. So Pat and I have been through a fair bit of this. All the credit for all the pretty slides and most of the ideas goes to Pat, but we've been through a lot of this, and it's been fun. If any of you know Pat, it can't be anything but fun. So I was going to go through and start in here with sort of picking up on part 2 of this talk. Okay? So in terms of the previous session, we had the Metropolis analogy and then practical advice for how to use some of that in building services today. Pat talked about avoiding ambiguity in messages, about idempotency in messages, talked about services for the enterprise. So I would claim that in the space of services, web services in particular, we're kind of at the Kitty Hawk age, right? And people are pretty much comfortable using it for getting web quotes and this and that, but how do we make these things enterprise ready and what's needed to do that? Message delivery in the cruel world. So guaranteed or reliable messaging means something different to everyone, and the question is always how guaranteed and how reliable and to how far. So implementing your business service. So Pat went through and made a distinction between services and business services, transactions and how to compose these things. We'll drill into that a bit more. And embracing and extending your apps. Again, we'll spend some more time in this part of the talk talking about that as well. So before I get into the meat of it, I want to just take a second and talk about an epiphany that I had probably 3 to 5 years ago, where we had an opportunity in shipping one of the SQL releases to go out and talk to there were 2 companies in general who were large e-commerce presence on the web. I won't mention their names, but they're both in business and doing quite well right now. One of them had gone and built what we would call today a service-oriented architecture. So it was their 3rd generation. They had taken the system and they had broken it up, and they had a tier of machines that was doing the catalog, and they had replicas of these machines, and they had a content master that they published off to these machines. They had another tier of machines that was doing shopping basket and maintaining shopping baskets. They had another tier of machines that was doing the user profile, so it had my address and credit card number. Then they had one machine in the back end that was sort of the order processor, and it consumed ordergrams from all of these other tiers, and they put this thing together. It was their 3rd generation. It was a natural pattern. They didn't read it out of the book. It's something that they pretty much independently stumbled on. And then had another opportunity to talk to another company who had gone the big iron route. So they had the $3 million 64-way machine and the very large database, put everything in one database. The problem they had was whenever anything went wrong, and it did, with the hardware or the database, they'd have to put up the banner ad and say, sorry, try again later. Our estimate time to repair is 8 p.m. And this was really kind of interesting for me. Now, the guys who had gone the other way and decomposed into what we'd known as a service-oriented architecture built it with baling twine and duct tape, okay? They put it together and they had little VB programs maybe that woke up every 30 seconds and moved things from one place to another. And people sometimes giggle when I tell them that. But the funny thing about it is they built this thing and it was more resilient to fault and more scalable than the other system. And so for me, this was really an epiphany. And one of the interesting things that came out of it was the distinction, how they had recognized the different classes of data around the application. So the replicas of the catalog, they never backed up. If one of those machines went up in smoke, they'd wheel in another one. If they needed more capacity, they'd just wheel in another one and push a replica down to it. The user profile information didn't change all that often. It was fairly static. So they had a different policy for managing it. Shopping basket data, they never backed up as well, because maybe their policy was it's only good for 90 minutes and they'll cancel it if you don't actually submit an order. So it was kind of fascinating to see how they had done this. And then the order processing machine, they took good care of that, and they shipped the log elsewhere and had multiple copies of it. So for me, a lot of what appears throughout this deck is really reinforced from that, and we'll visit that as we go through this. So data inside and outside of the service is very different, and we're going to spend a lot of time throughout this entire talk describing those differences, why they're there, why they're natural, and how we can exploit those inside the service and outside the service. So Oops, pressed the wrong way here. So consider data and messaging in the service. So we want to talk about the space between the services, okay? What goes into the messages and why? What's the schema between the services? So the interesting thing here is we need sort of universal knowledge of what the format is, so anyone who wants to participate can understand the format of the messages. We're going to talk about service agents and service masters. This is one of the key principles in this talk, and we'll spend a fair bit of time with a couple of examples of what these are. Ownership of data in the enterprise. So this is interesting as well, as how do we maintain particularly distributed copies of data? And then representations of data. How do we represent it and what form should it take for us to operate on it? And then we'll pull it all together and talk about the different roles of XML, objects, and SQL. So story I had is we built an XML data type in Yukon, the next release of SQL coming up. And we had a bunch of people from the company come around to decide what we were going to do about it 3 years or so ago. And as I've said, we had every point on the spectrum represented, lunacy at both ends. So we had the XML guys who said, relational databases will be, irrelevant in 5 years. Let's go build a native XML store. And then we had some old gray guys like myself who said that, yeah, we remember object databases too. Let's just wait 5 years and this will pass as well. So we wound up somewhere in the middle where we have an XML data type that you can use where applicable within your schema. So you can use it to augment relational schemas. Or if you wanted to build an XML store, what you can do is come up with a schema that is mostly an XML document. And those XML data types can be bound to XSD schemas or not. So let's talk about between the services for a few minutes. So one of the interesting things about between services is it's all about the messages, okay? Nothing else. If you understand the contract, and it can be heterogeneous. Focus on the messages. We're not talking about idle here or anything. It's the pieces at the other end that you can implement independently, heterogeneously, after the fact, and have the whole thing continue to work. We're going to talk about service requests and service response. Pretty much everyone in the room understands request-response patterns. This is the simplest. Now, the interesting thing is when we get to the end of this talk, we're just going to mention a handful of patterns and a handful of other different concepts, but be able to actually do a lot with them. Okay, so one of the things we're going to talk about are requests and response, and then reference data. This is an important aspect as well. So messages can carry reference data, and by this I mean catalogs and whatnot. So I would argue that Amazon.com would not be nearly as useful if it didn't have a catalog. Okay, and it's data used to fill out requests. Messages can carry either requests or responses or reference data as well. Okay? So reference data is something that we need to complete or generate requests. And we can get it to someone generating requests in many different ways. So I worked with some automobile dealers way back when, and they used to do it in CDs. So every quarter they get a new CD that they'd stick in the machine, and that was the reference data that they used to compose the requests. So data is sent from the publisher to a subscriber, periodically updated, and always versioned. This is really important. We'll talk about that in just a minute. So this periodic update may either occur in batch, meaning I get a new CD every quarter, or incrementally maintained as well, or a combination of both of those. So just like a department store catalog. So let's take a look at these two services again, reinforce the point. We're talking about reference data that's used by service B in formulating requests back to the service and getting responses back. So now we're just talking about messages and what can flow within messages. Reference data, requests, and responses. So this is a really important point here about versioning of reference data. Okay? So reference data has an identity. Pat talked about identity and talked about stable and immutable data in the previous part of the talk. Okay, so we mentioned that reference data gets updated, and we need a versioning scheme so that we understand which version we're talking about. So in this particular case, we're pushing copies, either batch updates or incremental maintenance of some reference data, and then a request references a particular version of reference data. Now, there's a real-world analogy to this, and it involves if you ever mail order anything, and you call up, and the person on the other end will say, what's the code on the catalog, or which catalog are you calling from? And it may be the case that certainly the latest one they understand. They might let you order from last year's catalog. But if I had in my hand a Sears catalog from 1923 and wanted to call and order a buggy whip that was on page 18, something would certainly go wrong. So it's really important that requests refer to the particular version of reference data that they want to act upon. So let's talk a little bit about schemas in the space between the services. So XML has pretty much grown up over the last few years. It's a very fine way of representing schema and representing messages. Okay? Grew up in the document world. Core tenets are independence of definition. Anyone can add stuff on it. I can compose things quite naturally, and I can extend it independently. Sure, you could add stuff to it. I may or may not care, and I may or may not understand it. So for those who have maintained network protocols, particularly sophisticated network protocols over time, realize that this is a really important thing, extensibility. So I had the misfortune when I was at DEC to inherit the remote data protocol for one of their database products. And unfortunately, I got it right after version 1. And the guy who had done version 1 didn't ever think there would be a version 2. And so it was really hard to shoehorn that all in. So this is an important aspect of the schema and describing things, because everything in a distributed world cannot be updated atomically. So you're always in a situation where some version's talking to a down-level or up-level version as well. So let's talk a little bit about info sets and schema and how we can pull those two things together. So an XML info set is about the tree and the semantics of the tree. It's not about the angle brackets, okay? And it encourages schema. Any representation is okay. Again, it's not the format, it's about the tree and the structure of it. XML schema gives us a data type library and a schema definition for composing more complex types. These things can be composed together uniquely and have an identity, so we can reference other portions of schema and pull it all together. So then we pull this together and talk about validating an XML document or message. And what we wind up with after we've run it through validation is what's known as a post-schema validated info set. And this is really interesting because we can leverage knowledge that's in the schema. And the way I look at this, it's if you have an XML document with no schema, if you want to go find things, you have to go spelunking, okay? You have to go descending through to see if pieces are there and then go from there and operate through it. If you've gone through and schema validated it, you can reason about what the shape of it is without having to go spelunking. And so it makes life much, much easier. And we'll talk about an analogy with this with contracts later on in the talk as well. Okay, so immutability, info sets, and messages. So Pat talked about the reasons why messages themselves should be immutable. And the key thing here, it's about the content or payload of the message. It's not about headers and rewriting those. It's about what is actually embodied in the request to the service itself. Okay, so info sets and messages, once they're written, and it's outside, and that's the way the other guy will interpret it. So every message, if we pull this together with XML schema, should have a schema that describes its contents. It can be defined with unique ID, typically a URI, and you should be able to find and bind to that schema based upon that ID. So XML schema is just a fine way of doing this, okay? It's a well-established standard, and again, to reinforce this point, we can program to extract the parts that we understand and ignore or pass through the parts that we don't. And that's a beautiful thing. So climbing the Tower of Babel, this is kind of interesting. And the story I tell is way back when I used to work at a place where, actually it was a division of Lockheed, and we had lots of networks, and this was in the late 80s. And we were spending a lot of money getting information from one system to another, whether we're down to the plant floor for manufacturing systems, between engineering automation systems, for hardware design, people doing simulation, people doing schematic capture and whatnot. And just moving the bits around was sort of our biggest challenge. Because if you had the IBM guys in there, they'd tell you to use SNA and LU6.2 and all this other stuff. If you had the DEC folks in there, they'd tell you to use DECnet. If you had the Sun folks in there, they'd say TCP is the way to go. Well, we finally decided we were going to carpet bomb the whole division with TCP. Well, that was the first part of it. Then we got to our PCs, and if you go back this far, you remember there were at least a dozen TCP stacks that you could use for your PC at that point. So moving the bits around was sort of our challenge 15 or 20 years ago. Now we're well beyond that. We have connectivity, but we're trying to figure out how to operate at a higher level. So understanding the semantics of the business data and the messages, that's our challenge today. And understanding the semantics of business operations. We'll spend some time focusing on that. So we're ratcheting our way up this stack and reaping the benefits of the things that we have beneath us. But contract rationalization and how we communicate is still nascent. Okay? Let's talk a little bit about how two things communicate in the face of change across them between two services. So there are two ways of doing this. One is known as a reader makes write approach, where the reader understands different formats and does transformations to make it right. So here's a graphic that displays this, whereby in the reading service, it may get a message of a particular format, and it needs to do a transformation such that it understands the message format. And you notice that some of these little shapes in here copy through directly, while other of them require transformations. Okay? So this is a high-fidelity way to do this transformation, but it requires a lot of knowledge about the other side. In fact, it requires knowledge about all of the other formats that you could possibly accept. Okay? So everybody knows everyone else. And here's an interesting graphic to describe sort of the combinatorics of this as the number of the services increases. So if we have 12 services, that's 12 times 11, 132 message transformers we need to pull this off. So obviously it's difficult to scale. The other way that we can approach it is to come up with a canonical schema that we agree to. And we may have to do some transformations to get into it, but the number is far fewer. So we transform to and from this canonical representation, and if everyone implements one of those transformers, we can all participate. The interesting thing about it is it's double lossy. There's some loss in the transformation to the canonical schema, and there's loss from it as well. What's interesting in this case is that in places where there have been consortia or people coming together to agree to something from the outset, there's been a pretty good investment, and you'll see markup languages in various domains where they've tried to capture this, which when they do that, they come up with a canonical schema that's actually very close, and if they all start from that, it doesn't require as much transformation on either end. So classic solution is to do a bit of a hybrid. Okay? Try implementing canonical schemas where possible, and only specialize where needed, whether that's on message type or whatnot. So again, this is a trade-off between cost and complexity and fidelity in different approaches that you can use there. Let's talk a few slides about early versus late binding. People understand this with respect to code and what it means there. Let's look at it in terms of services and messages. So in early binding, all of our details are known up front. Okay? Classic method calls are early bound. Everything's known in advance, and we can exploit that. For late binding, senders can add additional stuff, and we can interpret it, okay, at runtime. So the receiver might look for added stuff. So there's two dimensions here that I just want to kind of tease apart. In this particular case, we're talking about booking a flight, and the important stuff is that I get from Seattle to LA on a particular day. Okay? The rest of the stuff is optional. Okay? Now this optional information could in fact be early bound, but if we tease these apart, what we can do is say that others on the other end can use parts of the optional information to give better service. So in this particular case, the key things that need to be conveyed is that I want to fly from Seattle to Los Angeles on the 25th of October. Optional parts would be I prefer an aisle, a morning flight, and my particular airline as well. Okay, so this is an important piece of this. So challenges, advantages of late binding are flexibility. Okay, they can evolve independently. Okay, the challenge is it's hard to write the code to interpret the data. And one of the things that we found when we were thinking through WinFS is that we wanted extensions. So we wanted to say that instead of having 5 address books on a machine, can we get it down to 1 and other people can augment it, such that if I go to write a check from a particular finance program and I have someone in my contacts, I don't have to type in the name and address again to mail them the check. So with the extensions, what this graphic is showing is that there's the part that we need to know about up front, and we can pivot around that and interpret the extensions independently. Obviously, the challenge in this is if the extensions evolve independently, how do you rationalize competing extensions? So I may have 2 things in separately evolved extensions. They're in conflict if I understand both of them. And how do I resolve that? So there is a tension here between being able to express things that are not known and being able to have those things go independently and be able to make sense of it. So you can think of extensions in 2 dimensions. One is for evolution of something that both people know about, and the other is for adding information that services may or may not know about to have a higher fidelity or higher level of service. Okay, so let's talk about late binding. So what is the minimal required and what can be optional? So in terms of what should be the minimal required, we should try to codify what humans know is minimal. And there are a lot of analogies in this talk around how do we think through how humans process things, and how do we turn that into an automated process, and what is good enough. And one of the ways we get ourselves into trouble as engineers is trying to develop things that are 100%, when we can get, in terms of a cost to benefit, something that goes 90, 95, sometimes even 80% is of tremendous value. Okay? So a different attitude about maximizing independence. And here's a point. We may want to record all of the incoming information, the extensions, even if we don't know how to interpret them. And this is for auditability. Perhaps we're passing it on to someone else, or someone later may come along and know how to interpret them. So use optional data for adding value, as well as extending and providing independence and evolution. Okay. So now we're going to talk about service masters and service agents. And this is something that will come up throughout the remainder of the talk. Okay. In order to introduce this, we need to go and talk about two different classes of data. And we're going to talk about that as resource-oriented data and activity-oriented data. And we'll go through a little bit of a thought experiment here in a couple slides to pull this all together. So resource-oriented data is sort of the line of business or the back-end data. So inventory corresponding to SKU number 71946, a particular bank balance, customer info. Typically, it is long-living, okay? We hold on to resources for a long time. SKUs last for a long time. Customers last for a fairly long time, as do accounts. And then there's activity-oriented data, which is used, typically its lifetime is bound to the lifetime of the business transaction. And it retires on completion of the long-running operation. Okay? And we'll go into a couple of examples of this. So these classes of data have different characteristics, and we'll exploit them. And it was kind of fascinating to go back to the thing, you know, the two people who had built these commerce sites. One of them had lots of activity data and was able to exploit it, and the other one didn't. Okay? So activity-oriented data does retire. Okay? And frequently, though, these business transactions will take months, weeks, months, or maybe even years. But eventually, they do complete. Okay? Activity-oriented data retires, and it becomes read-only. It gets referenced less and less frequently. We typically want to hang on to it and use it for business intelligence or mining. And in the area of compliance, where there are a lot more laws going around in terms of holding on to data, there are products out there now you may be familiar with known as content addressable storage, where these are boxes where I can store items in for compliance. And what I get back is an identifier, an identity. And there's no way to delete anything from these boxes. Some of them have two modes. There's one that'll let an administrator or someone who's trusted delete them. And then there's another switch called the SEC switch, which means no one can delete anything from the box unless they take the disks out and physically destroy them. So in this particular case, you'd want to hang on to the data. So let's talk about my thought experiment for activity-oriented data is if anyone has eaten at a sort of a greasy spoon, okay, so a restaurant of that form. You can imagine when a waiter or waitress comes out with a piece of paper, they have a pad and they have a pen, and they take your order, okay? And they take that order once you're complete, and they go, and there's this rack that they stick it on, they spin it around, and the short order cook back there is the one who actually goes and cracks the eggs and does your order. When it's done, he spins it around, rings the bell, comes back. The waitress will come back and place your order on the table. You'll eat your meal, maybe get another cup of coffee. In the end, you take that slip of paper, you bring it up to the cashier, they'll ring you up, you pay some money, and at that point there's usually a spike right next to the cash register, okay, this big long spike, and the cashier will take it and just slam it down on the spike, and that's when the data gets retired in that case, okay? So that's activity-oriented data that got retired. So if you think about the short order cook, now he's the guy who's actually committing eggs to do the job. Now that's resources, okay? And so we'll go back on this theme a little bit, but that's sort of a little bit of an experiment in terms of what is an activity-oriented data and what is resource-oriented data. Okay, so resource-oriented data does retire sometimes. So you go through periodically and purge customers or purge SKUs. Some resources have a bounded life where we'll bind activity-oriented data to resource data. We'll talk about that a little bit. So particular seat assignments on planes or particular room assignments in a hotel. So now let's talk about service agents. If any of you have seen Pat's prior talks about fiefdoms and emissaries, there's a lot of analogy between these two things. But a service agent is a special type of service, and it manages activity-oriented data. It lives for a single long-running operation. I should say it's bound to a single long-running operation. It does not typically directly use resource-oriented data. So it uses activity-oriented data, requests and responses. So it's the one who can interact with the messages, and it uses reference data. So it's also interesting to note that the service agents are easy ones to scale. So if you go back to the example of the Greasy Spoon restaurant, as long as I have pads and pens and people who can act as waiters and waitresses, I can scale that pretty easily. Now, the grill itself is harder to scale, and I need to do an efficient job of managing the resources back there. But in terms of scaling, it's typically easier to get the service agents to scale. Let's talk about service masters, okay? They're actually performing the requests and committing the resources and actually modifying the resources directly. They live longer, are bound longer than a long-running operation or business transaction. And these use all kinds of data. So reference-oriented data they may use directly, activity-oriented data they'll use, request response, so the message data, and reference data. So it should be, one of those should be resource data. And this is very similar to what used to be called fiefdoms. Okay. So this is a very interesting slide that sort of shows how activity data, and there's a couple of very key points on this slide. One, we have a customer service operation that begins and is going to start a purchase order. And notice that we do this within a transaction, and we actually create some activity data and actually commit it into the database. And then we use reliable messaging to get that request over to another system, at which point we consume that message in a transaction, we create some activity-oriented data over there, and we generate an outgoing message all within one transaction. Okay? And we commit that transaction. Then we go over in the credit check service. So the purchase order needs to go off and do a credit check, in which case it goes through the message from the credit check service is consumed within a transaction, and it generates a response. Now notice that transaction 4 that we just got actually rendezvoused with the activity data. So at the point where the database was at after committing transaction 2, we had activity data that was committed and durable in the database. But we were waiting for a response from the credit check service. The beautiful thing about this is that at any point in time, we can pretty much shoot this whole thing, any of these processes down, and the right thing happens. So imagine that the purchase order service had gone away while we were waiting for the response from the credit check service. It's all maintained durably in the database and in the reliable messaging infrastructure. So that activity data would have been committed into the database. Once the purchase order service came back up, the credit check service would have pushed through the message that we show here corresponding to transaction T4. At that point, it would have rendezvoused with the activity data to proceed. And notice that the activity data in this case has turned gray, so we've actually retired it. From the perspective of the purchase order service, this particular business transaction is done. Response for T5 goes off, again, rendezvous with the activity data and retires it. So key thing about this is severalfold. One, multiple database transactions that compose a single larger business transaction. No two-phase commit going on here. Activity data is actually committed into the database and rendezvoused again with other portions of the business flow. Beauty of all this is that I can take and I can shoot any of this down at any point in time and the right thing happens. It's very reliable. So you can see how the activity-oriented data comes along, activates the data, may rendezvous and activate it again, and then when it's all done, we'll retire it. Okay. So let's talk about ownership of data in the enterprise for a few slides. So interesting slide here in terms of mainframes and monoliths. And this is interesting from the perspective of the story I started out with. Now, the one company that had put everything together in a single large database and a single large machine, ultimately, they ran out of gas. They couldn't meet the level of service that they wanted out of that machine, and they partitioned the application into various pieces. But it was pretty difficult for them to do it because they had access to everything in one place. They didn't think about factoring the data from the outset. And so it was pretty difficult for them to pull it off, but ultimately they did. So when everything is together in one monolith, it's all very close. And so you don't think about the distance between data and the types of data that are involved. So I can take one transaction, operate on all sorts of different things. So I don't really consider what could be activity data, what could be resource data. It all looks the same when it's in one database unless you take special care of that. So interesting thing, mainframe apps are moving to different machines and different transactions, and how do we pull all this off? So here's an interesting graphic that shows that we can have services around the box, and then how do we go and actually fracture these and pull them out onto distant machines by maintaining copies. So, okay. So when there's data needed by many, okay, customers, employees, parts, each piece of data should have an owner, okay? And we should publish changes to others, okay? And a lot of what EAI is about has to do with some of this, but we don't think about it generally in terms of publishing inversioned reference data, okay? So what we'll go through here in this particular graphic is there's an authoritative copy of data. So another way of saying this is the truth can only really be at one place, okay? Anytime there's distribution, there's fuzziness about what the truth is. And if you've read, Stephen Hawking's book, there's the event cone, right? So if the sun blew up 7 minutes ago, we wouldn't know about it, okay? So the truth, if you're closer to the sun, you recognize that sooner than the truth would be right here. In the end, everything will converge and we kind of wind up the same state. But there is sort of this fuzziness when there is distributed truth. So in this particular case, we have an authoritative copy of an employee. We can update it, increase the version, and then publish the update out to others as reference data that then we can use to come back in. And we'll show how we can actually propose updates to the master in a very careful way in a couple of slides as well. So if any piece of data has a single owner, it's got a private view of the data, and it publishes the public view of it, okay, what others are going to consume as reference data. You can't have multiple owners. That's a pretty strong statement because we have replication schemes. But whenever you get into conflict resolution, things get much, much more difficult. So if you can keep it in this pattern, life is much easier and much crisper. So partitioning is just fine. So you can partition by topic and application, partitioning by region. So one of the natural things that falls out of this, look at things this way, is typically the service agents correspond to data that's easily partitioned. If we go back to the original story, I could easily partition shopping baskets based upon some session ID. I could easily partition user profile data based upon some other user ID. So those partition quite well. Whereas the resource-oriented data is sometimes more difficult to partition, but it can be as well, particularly when you've got things factored as services. So we'll talk about that. So pushing out versioned replicas. So if the owner of the data periodically publishes it out, it can use whatever it wants to get it out there. Publications are always versioned such that requests know what they're referring to. And go back to that picture again where we've got versioned reference data coming across and then the request that corresponds to a particular version and actually references a particular version. So I had a chance to talk to a few people at a conference a couple weeks ago who are out building service-oriented architectures, and many of them are building versioning schemes, if you will, in sort of an overlay network. So where you could get reliable delivery of messages from queue to queue, and you never saw the version numbers from the application perspective, some of these folks were actually building it up at higher levels. So in the data, they had actually built in versioning numbers in the messages that they had sent around and in the versioned reference data. And I get the sense that they wouldn't go back at this point. They've learned a lot from that. Okay. So now here's how we can request that the owner would make a change on our behalf. So there's still one owner to a particular piece of data. And if I have a particular version, what I'll do is actually pose a request as a service request to the owning service of the data and have the publication or the change trickle back. There's actually a version of SQL Server replication called queued updates, which basically does this. So there's one master of the data, but what I can do is propose updates to it and realize that this actually converges quite well, because if I have the request is based upon version X, and if someone else has made a conflicting update, what I can do is not honor the request, tell them that there's been a pending or a conflicting update, then they can wait for the update to propagate back through and then pose the request again. So I'm going to spend a fair bit of time talking about representations of data. So we talked about resource-oriented data. We talked about versioned reference data, request-response data, and activity-oriented data. So 4 different classes of data. Pat mentioned in the previous talk about immutability, a normalization of data, stability of data, and concurrent updates. So for resource-oriented data, it's typically not stable. Okay, and we'll talk about that a little bit later on. Typically, it is normalized. Pat described why that was important. Is it immutable? No. Typically, it's very volatile, or I should say attributes of resource-oriented data are volatile. Some of them are non-volatile. So if I think of an inventory, the SKU is stable or static, but the inventory levels themselves are very volatile and updated on behalf of many service agents. And by virtue of that, it's a highly concurrent update. For versioned reference data, it's typically stable. It may or may not be normalized. It's immutable in the sense that it's only written once, and it's not updated. Now, for request response data, again, stable. It may or may not be normalized. It's written once, so it is immutable, and there's no update on it once it's written. So what's interesting is, we'll take a look at it in just a second, how those two are the same, and that's how we're communicating between services. So for activity-oriented data, it is stable, may or may not be normalized. It's typically not immutable. We make updates to it, but very low concurrency on that. So imagine shopping baskets. So I modify my shopping basket, so it is volatile in the sense that it gets modified, but I don't necessarily have to reach out and touch someone else's shopping basket. It's typically mine, it's partitionable, and it's not highly concurrent. So activity data, again, rarely concurrently updated, tends to have simple and private structures, which we'll get into a little bit later. Version reference data and request response data never change. Now these are the things that are flowing between the services. And then resource-oriented data as well. So let's talk about the relational revolution and how relational databases have changed things. So obviously, relational model calculates values by relating values within a database, okay? And that database is the consistency domain. I can relate anything to anything as long as it's within that database, okay? What the relational guys had done way back when, that actually has been amazing how it's played out over several decades, is to separate the data from the logic. And by that, I mean, well, the first job I had at Digital, I was the project leader at one point for the DBMS, which was the codicil database product, okay? And I used to pride myself that for certain manufacturing operations, we had to do bill of materials and this, I could do it much, much faster than the relational guys could, okay? Well, now we're at the point where the relational guys could do it faster and more flexibly than I could. Because in the codicil database, it was part of the model to chase the pointers. But this abstraction between the data and the logic has given a lot of leeway to the implementation to do things in a very fast manner. And it's amazing the tricks in all of the relational databases today that they have for solving queries. And it's the separation between the data and the logic that operates on the data that has allowed them to do such a great job on this. Whereas contrasted with the codicil model, which made it go fast 20 years ago, actually slow it down right now in terms of chasing pointers around. So SQL also has premier data management. So big investment in these relational databases over the last couple decades in terms of online backup, high performance, archival, other management features. I think this is one of the key reasons why object databases never really took off. It was an issue with the domain, it was an issue with some other things, but when it came to, do I have transactions? Do I have online backup? Do I have all these other things? Do I have online index build? They just didn't have them, and it's been decades of investment from the relational database folks. So in terms of the relational model, it's bounded, okay? So operations occur within the database. Value comparisons are only meaningful within the database. And it's a tightly managed schema. And I need that in order to be able to do the relational constructs. So XML info sets, on the other hand, are unbounded. It's an open, extensible schema, and I can compose it from contributions from many different places. And there are references, not just values. URIs are known to be unique, but info sets, if you know how to interpret things, can be interpreted anywhere in space and time. It's not the same case for relational databases. So let's take a look here about objects, components, and complexity, and managing complexity. So for those of you who've been around, for the object revolution and went from structured programming to object orientation way back when, for me, the epiphany there was that I could think about larger design problems in two spaces. I could think about the objects and sort of the flows between objects, and then I could think about the implementation. And it was really liberating in that sense. So I could, from a software engineering standpoint, I personally could scale my design skills further. So the essence was encapsulation. I could actually design the system in the large without worrying about the implementation, as long as I had the interfaces correct and as long as I had the factoring correct amongst the objects. So durable objects are not very well established. People go off and build durable objects, but if you think of the object databases, there was a chance for us to go off and do durable objects, but they never really took hold. an object, as I said, object database is not a big success. And there's a lot of work to persist objects via the SQL store. So in one sense, any time anyone often builds a business logic tier or business objects, they do some of this. We'll talk about that in the next slide. So now, let's talk about encapsulation of durable data. So objects encapsulate data, and SQL and XML are naturally durable. They're easy to put down into the database. Components can then encapsulate durable data. Okay, so we'll talk about this again. So kinds of data, the 4 kinds again: request response, reference, activity, and resource oriented. Let's go through and look at them from this perspective. So request response data, is it private to the service? Absolutely not, because all of the services need to be able to interpret the data itself. Does it need encapsulation? No, again, no, because I want it to be open such that everyone can interpret it. Can it be represented in XML? Yes, sure, it's a great way to represent it. Is it concurrent? No, because it's read-only. It's only written once. We don't really have to bind objects to it, and we don't worry about concurrency because it's immutable data. Same pattern for reference data as well. And again, just to reiterate the point, request response and reference data are the only things we have flowing between services. So activity-oriented data, let's take a look at this. So again, this would be like a shopping basket as an example. Is it private to the service? Yes, it's not something that I flow between the services generally. Does it need encapsulation? It makes my life easier, because if I'm programming against the shopping basket, all I want is the interface that says, add this item to the shopping basket, remove it, clear it, update the basket. Represented in XML? Potentially. Concurrency? Very low again. We talked about activity-oriented data as not being concurrently updated. Object style? Object persistence would work just fine for activity data. And optimistic concurrency approach, as I said, because I'm not going to hold locks on this, I'm just going to actually work on it locally. And if I do need any concurrent updates, I could do it optimistically. From a resource-oriented data perspective, again, it's private to the service. It can benefit from encapsulation. It could be stored in XML, but typically not. Generally, very high concurrency for some attributes of the resource-oriented data. And object style, we build these things today already. And we typically use pessimistic locking of real database transactions to modify resource-oriented data. Okay, let's talk about persistent objects in SQL storage. So people have been doing this for a long time. There's actually something that we showed at the PDC last week known as object spaces, as a way of rendering objects into the database and doing this mapping. So persistent objects, again, encapsulated by logic. A lot of mid-tier logic we build out this way. The data is kept in SQL and uses optimistic concurrency, typically, because what we do is pull together, generate the business object, and then write it back into the database at some point. It can be stored as a collection of records, and we'll show how we generally do this. So we come up with an object with an ID that may be an artificial, synthetic ID, or a real-world ID, and then basically write it into the database using that ID and being able to pull it back together. So this is standard stuff. A lot of people do this. So you can generate mapping technologies and you can build this up as an infrastructure, or a lot of people just do it ad hoc when they go to build the solution. So if I've got a customer business object, I'll go pull the customer up. If I have an order business object, I'll pull the header and the line items out of the database and render it as an object, and I can operate on that. So let's talk about stateless objects in their relationship with service agents and resource-oriented data. So we mentioned again that resource-oriented data has changed a lot, okay? Many different long-running operations. And each interleaving long-running operation may see changes since the last time. So this just makes sense when you start to think about it. So imagine I'm going to request, think of a phone exchange. I'd like to buy 20 widgets. That's just fine. I have 30 of them on hand. And you go and you think about it, and then you submit the order for 20. Now, it may be the case that someone else has come along and purchased 10 during that, and the guy on the phone will say, oh, I'm sorry, we just kind of missed it. So you will see changes to resource-oriented data, because typically I'm not going to lock it during the business exchange. So we're going to let those other things float so I can update them concurrently. So stateless objects provide operations, and there are a number of different techniques we can do around this, and we'll show some of them here in a minute. So reserving a hotel room or ordering parts, I don't necessarily commit specific parts to it, and I use these stateless objects to provide and implement these operations. And they can have more and more sophistication around what sort of resources they hold or they correspond to. Again, we'll get into this in a few slides. So we're going to look at this one more time in terms of the different types of data and then distill it down into something that's very simple. So in this particular graphic, the different types of data are along the top: request, reference, activity, and resource. So again, hammer home the point again, open schema for interop makes sense for things that are going across the services, not for things that are private to the service. For encapsulation, it doesn't make too much sense for those things that we're using and going across services, but it does for those things that are private to the services. In terms of immutability, again, those things that are flowing across services should be immutable. Okay? Those things that are within the services have varying degrees of update. So here's an interesting one: fodder for business intelligence analysis. I would claim that they all are. And so even to the point, I think one of the points that Pat mentioned in his talk is that maybe you want to record the reads. And so a great example of this is web logs, recording the reads and the hits against a website. And we use those and mine them for a number of different purposes. So storing the request response and maybe potentially the reference data is very interesting. We had a case probably a couple years ago where there was a company that was building a large data warehouse on top of SQL, and we asked them, it was point of sale data. So we asked the folks, we said, well, what are you going to do with it? And they said, well, we don't really know yet, but we know it's too valuable to throw away. And so they're going to go collect it all and then figure out what to do with it. And it's an interesting thing when you realize that how much of the data nowadays is born digital. Or if you go back 20, 30 years ago in terms of key punch operators and whatnot, having people key it in, now so much of it is born digital, and the cost to store it is so low that it does make sense to keep this data around. Okay, so in terms of, this is pretty interesting, sort of the contrast between the data that's going across services and the data within services. And we can distill that into, does it make sense to represent it in XML? I would say yes for those things going across services, probably not for those things that are private within the service. So you could make a case for it in some cases. So business intelligence, okay? Durable storage in SQL, I would claim that if you're going to be storing your messages and you're going to operate on them, then you probably do want to keep a copy around the database and use some of the analysis services of the database to get at it. And so there are tools. With Yukon, we can actually operate on XML data directly and query over it using XQuery, or we can shred it into a different form that we could use to analyze it. And so encapsulated access, again, no for the things flowing across service, and yes for those things in the services. So let's distill this all down. So now look what we've got. We've got representation in XML, and a case for XML, and a case for when you wouldn't want to use XML. Durable storage in SQL, so when we would want to store things inside the database, and a case for encapsulation in some aspects of the data and not encapsulating other pieces of it. Okay? So let's take a look at this from the, if we will, the ruling triumvirate of the various, you've got the SQL folks. SQL, again, fantastic for comparing anything to anything as long as it's within the bounds of the database or within the schema. We have XML, so we can have independent definition of the schema and be able to interpret reasonably at various places and different points of time. And components and objects, providing encapsulation where necessary behind data. So ensuring enforcement of business rules and easing composition of logic. We talked about that a few slides ago as well. So let's use those things and talk about the strengths and weaknesses of these different models. So for arbitrary queries, we would argue that SQL is the ruler here. Okay? As long as we can relate things, we can pose reasonable queries over the data. That's not the case in an XML store because we have varying degrees of schema and varying pieces. And as we start to extend it, we have conflicts between the extensions. For objects, it's really impossible for us to do arbitrary queries because unless someone's provided a method for us to get at something, we can't see inside of it. So independent data definition. For SQL, it's not possible because the schema that binds us is also one of the things that makes sort of the arbitrary queries possible. For XML, not only is it possible, it actually works quite well. We can compose these things independently. And for objects, again, I can't see the schema, so I can't do independent data definition and have others make sense of it. So if you think about it, there's sort of an interesting thing here around encapsulating XML with sort of business objects. It's fine for the part that you can understand, but if you've extended it, it gets kind of interesting in how you compose the logic around it as well that's encapsulating it. So encapsulation, for SQL, it's not enforced by SQL. lots of people can build it. So in many cases what you'll do is actually build a business object, grant access to various underlying tables to the business object, but not directly to people, such that they could modify tables directly. XML, it's impossible because we have the open schema, or it's a challenge. For those things that you know about, you could bind to it and encapsulate it. It may actually get some value from it, but generally the models don't fit together very well. And then with objects, it's all about encapsulation. Okay, so each model's strength is ultimately its weakness. Okay, so now that we've laid all these things out, looking at the different forms of data, looking at reference data, let's kind of pull it all together. Okay, talking to the world, we made a very good case, a very strong case for using XML to communicate between services. We talked about interactions across services in very simple terms: requests, response, and reference data. In terms of storing the data, with respect to business services, we can implement one or more service within a business service and encapsulate a collection of private data. Again, we said within the service, it's generally private data. Makes sense to store the data in a SQL database. We made a case for activity data, why it makes sense to store it durably and transactionally in the database as well. In storing incoming and outgoing messages in SQL. So for auditing, for compliance, for business intelligence. And that's one aspect of it. The other beautiful aspect of it is durability and being able to use standard messaging techniques such that in these architectures, I can take any piece of it and shoot it down, bring it back up, and the right thing happens. So these two things together, using transactions and storing activity data in transactions, using durable and reliable messaging technologies to get messages between systems, all composes very nicely. Okay, so then we'll talk about implementing the code, where objects are just fine here. So they encapsulate the parts of the service that are private, and we made the case for the private parts of the data. They're the best thing we've got going for software engineering, because we can decouple the implementation from the interface, and we can encapsulate the data. Okay. Objects, we can have a composition of objects themselves inside the business service, and making it easier to build and evolve. We all know this stuff. Okay. So putting it all together, here's the slide that makes the case that we need all of these things in different pieces. So XML messages and info sets for messages between the services. I made a very strong case for why that makes sense, why we don't need encapsulation. Made a very strong case for objects to implement the business logic. It's what we have today. It works quite well. And we made a very strong case for SQL holding the data. Now, we may have made a case that's stronger than what you would consider today. We started talking about the activity data and why it makes sense to put that in the database, and for the message data itself. Okay. So now we'll go through this section here, thoughts on business processes. Okay. So how can we take what we have in terms of request and response and compose more sophisticated things from that? So how do we reach agreements without transactions that span services? And so there's an interesting debate that goes on around distributed transactions and two-phase commit and all of this stuff. And what I find fascinating is people like yourselves who are out building real systems generally understand the applicability when you'd use one and when you wouldn't use, when you'd use two-phase commit and when you wouldn't, probably to a degree that the systems implementers, the guys implementing the plumbing, don't understand. And so how do we interact with service masters and service agents? We're going to talk about tentative operations, adding another thing on here that really increases the level of sophistication that we can go after. The power of managing uncertainty. This we all do quite easily in our brains, but how do we teach our systems to do this? Talking about schema, contracts, and service level agreements, the black box behavior and how we can compose these black box services. Wrapping existing apps with business processes, business services. So at this conference that we were at a couple of weeks ago, Pat and I, there was a financial house that was going and rewrapping all of their existing stuff as services, recasting them as services, and then they were composing new applications by binding to these services. How do we layer these things to have business processes? We'll talk about that. And then sort of a little tie-in at the end of extrapolating between the real world of retail and distribution and how we could use services to do the same thing. Okay? So multiple message interactions are kind of interesting because the behavior of every subsequent message depends on what happens on preceding messages. Okay? And unless we find a way to make this simple, the combinatorics rapidly get out of hand. So we have to remember what had happened before and associate new messages, new message context with what has happened precedingly. So a conversation gives us a sequence of messages between two services, okay? And we know that things got there exactly once and in order. So one of the things I heard someone mention recently is they talked of a durable TCP. So if you know UDP and you know TCP, there are advantages we get in a TCP connection. I have a session, I have clear teardown semantics on both sides. When there's a failure, I know that everything I sent is going to get exactly once in order delivery. If I'm programming to datagrams that can be lost, if I'm managing that myself and I have context that spans datagrams, it is very, very tricky to get it right. Or you can simplify it down to putting sequence numbers in it, making the request item potent, and only accepting the next one in the sequence. People do that as well. So having a conversation and a contract makes it much, much easier for us to build business processes. We'll talk about that a fair bit. Okay, I want to talk a little bit about tentative operations and how we can take and compose larger business transactions out of smaller database transactions using tentative operations. Okay, so again, business services generally don't share transactions because I don't want you to hold my locks while you make a decision on whether you're going to go, actually order the parts or not. So business services may accept tentative operations, which means, I will let you order some parts and come back and either confirm or cancel within 5 minutes or so. So if things are canceled, the business service must cope. It must compensate. It's not undo. It's not transactional undo. I don't put things back the way they were. I do some compensating operations that make sense for the business process. So here we have service A sending a tentative operation to service B, followed by a cancellation. We'll drill into this a fair bit in the next few slides. So one of the issues with tentative operations is they must be reorderable, because as a resource service or a service master, I'm processing tentative operations from a number of different service agents. And any one of them may either confirm or cancel. So how do I keep all of this straight when I have multiple tentative operations going forward at the same time? So they need to be reorderable, and I need to be able to compensate around various ones. Okay, so cancellation is coping with not doing the tentative operation. As I mentioned before, it is not undo. Okay, it's another operation that makes things right. So accepting tentative means it's okay to cancel. So when I accept a tentative operation from you, it means that I am obliged to either accept a cancel or a confirm from that point. So if you know how the two-phase commit protocol, it's kind of like the prepare phase. Say, I'm ready, I can go either way. I can either commit or roll back. But it's not like distributed transactions in the sense that the compensation is undo. Okay? So confirmation relinquishes the right to cancel the operation, sometimes time-driven. Okay? Both the confirm and the cancellation are time-driven. I think this is a really, really important point. And there are natural occurrences of this. So if anyone's ever ordered tickets from Ticketmaster, it's kind of a frantic thing for me, because usually I'm doing it while I'm on some slow connection, and I get these seats that I like. And as soon as you select the seats, there's this banner that comes up and says, you have 5 minutes to get through to the other end and enter your credit card and hit submit, or the seats go away, okay? He's done it as well. So it's a mad dash when you're on a 28.8 connection trying to get this done. But if you don't, it invokes a cancellation and rolls back the seats. So I don't hold a transaction at Ticketmaster for those 5 minutes. I have a tentative operation that will automatically go away if I don't finish and get to a confirm within 5 minutes. This is quite natural and very powerful as well. Okay. So every tentative operation either confirms or cancels. So let's talk about how this relates to service masters and service agents. So we talk about service agents encapsulating activity data. They never span. Now the service agent code, it lives, its process spans it. But the activity data is bound to one long-running or business transaction. Tentative operations for service agents are generally pretty simple. It means throwing it out. So imagine a service agent that is running a shopping basket, okay, in that example we had from the beginning. If I just walk away or if I cancel, the tentative operation is easy to cope with. I just throw out the shopping basket. Nothing is shared. So harder problems are in resource-oriented data. And that's because that's where the sharing is. And that's where I need to think about compensations. Okay? So shopping basket, everything is tentative. It's really trivial to cancel it. Or I could save it off somewhere, come back and rendezvous with it later on. Now, a travel itinerary may actually do more in terms of how I compose it. So I've got operations pending with airlines, hotels, reservations, and it's easier to manage tentative changes because of the business flow. I can go to Expedia, I can go look at a flight, I can come back in 24 hours and go confirm it. Okay. So resource-oriented data itself spans concurrent long-running operations. So sometimes we need to bind activity-oriented data and commit it to resource-oriented data. So we start thinking about inventory levels and account balances. Here's a case where we're talking about rooms. So when I go and I request a room from the Marriott or whatnot, they don't generally tell me I'm going to have king-size room 1, 2, 3, king-size non-smoking room. They commit to granting me a king-size non-smoking room. They're able to sort of order things around and manage the resources themselves. But my reservation actually is bound in some sense to the resource-oriented data because they can't or generally do not want to overcommit such that they can't honor my reservation. So this is kind of interesting and how tentative operations go against this as well. So this is activity-oriented data that's bound to resource-oriented data, okay, and ultimately commits and then or confirms or cancels. So long-running work generally needs tentative operations. It's a very simple way to think about the problem, but it really does help in terms of the complexity of what you can offer for service. It allows distributed commitment without distributed commit, or two-phase commit. The invoked service accepts the uncertainty. It bears the responsibility for either confirming or canceling once you've accepted the tentative operation. And again, reorderability is essential for tentative ops. Okay, so we've got a slide coming up. When you start to think about inventory levels, in terms of tentative operations, I don't need to worry about exactly which widget, but I want to make sure that I'm not overdrawn. And how do you manage that? We'll talk about it. Interchangeability provides reorderability. If I can commingle resources, one of the frustrating things about working for a defense contractor where if I go to a bank, I don't necessarily have to go see my dollar bill that I deposited yesterday. Dollars are fungible. I can get another one that's just as good. But working for a defense contractor kind of lets you know why sometimes hammers cost $500. Each individual program would buy components and they wanted to keep them separately. So it was harder for reordering and managing these things because the 126B program wanted to see the 126B 220 ohm quarter arc resistors and they'd actually come in and audit you for that. So being able to move these resources around and manage them gives you some flexibility with these tentative operations that you otherwise wouldn't have. Okay? So let's talk about managing uncertainty. So tentative operations increase uncertainty. You get more confused when you accept a tentative operation because you've got two outcomes that you're obliged to honor. Okay? So when I confirm or I cancel, it decreases the uncertainty. So if you think, if I have a number of outstanding orders for some particular SKU, I have uncertainty in the amount of actual inventory I have because I've committed some of that inventory, but I haven't really sold it at this point. So the amount of uncertainty goes up. But every operation that either confirms or cancels increases my level of certainty about what I actually have on hand. Okay? So again, every cancellation or confirmation makes things less uncertain. Every tentative operation actually increases the uncertainty. So we can track worst case values and have a bound on it. So tentative operations tend to move the bounds apart. So if I have 300 widgets and I have a number of tentative operations, the actual number of widgets I have on hand, the amount of uncertainty grows. Okay? And confirming or canceling any of those actually reduces the bounds. This should be minimum and maximum widgets. So there's a widget inventory with some probability distribution. Okay? And if there are no tentative operations outstanding, then I have a pretty accurate indication of what my inventory is. But as there are more and more tentative operations, the uncertainty grows. And what becomes interesting is there are interesting points in terms of I may not want to overcommit my inventory. Or if I know that some fraction of the people will actually cancel, I can exploit that to actually improve my efficiency. And that happens in real life. We'll talk about that a bit as well. So how do we act on bounded uncertainty? So we can have different business rules. So we can refuse an order if we don't have or know that we have the inventory on hand to service it. We can calculate the cost of temporary storage versus the value of accepting the order. So there are lots of different tricks we can play. Hotel, if we have a lot of people come in, we can order lots of food for our restaurant. They may or may not stay. Reservations might get canceled. Interesting potential for risk management. So just like futures and commodities trading, if you think of the airlines, they do this all the time. They overbook the number of seats, and they're betting that some fraction of people just aren't going to show up for the flight. Okay, so let's talk about schemas and contracts and what this can do for us as well. We talked about the message schema being shared. Reference data is published by some target. There's an industry evolution going on XSD for having a schema for defining the info set, and then a description language for defining the interaction with the operation. So in some sense, the WSDL, how do I, it's the marshalling of the operation. What's interesting about this is things are becoming more document-centric, moving things back and forth rather than corresponding to a particular method call. So I bind things together, and so I would say that these interactions are much more closely aligned with business requests than they are with method calls. So let's think about this way. If I'm doing a purchase order system, what I'm getting is a document that looks like an order request, not necessarily add line item, add line item, add line item method call requests. And so much more document and business document centric. No clear consensus yet on the formats. That's something that's still evolving. So we mentioned earlier, in some places, some domains, this is actually moving along quite well. In others, there's still a lot of work to do. So I want to talk about contracts, and this is sort of the sequences of messages that you go through. And so you'll send a purchase order. I'll either send an ACK or a reject. We'll talk about binding this into tentative operations in the next few slides. It's a nascent area, but what I think and the opportunity I see in this is the ability to bind business logic within the sequences. So for people developing service logic, I think it's an equivalent step. For anyone who started writing Windows programs way back when with the Petzold book, like 1,200 pages of processing messages and this and that, boy, VB was nice after that because I could just bind to operations and make lots of magic happen. I think the same thing could happen here in this particular space, where I can bind handlers to particular positions in the sequence of a contract and not have to worry about all of the other stuff if we can declaratively specify the contract. And so there is a lot of work going on in this space. So contracts and tentative operations. So how do we annotate tentative operations and follow them up with confirms and cancels? So the contract flow could define that. Then we have this notion of a black box definition of uncertainty. Which partner is going to resolve it? So let's look at this. So there's a source to target message that's shown here in yellow and a target to source message. So I have a tentative operation that says I'd like to place an order, okay, for the particular product, particular quantity maybe. Now, as the service logic, I can do one of two things. I can reject the order, saying I don't understand that order or product, I don't understand, I can't honor the quantity, or I can tentatively accept the order. Now, once I've done that, I'm obliged to either be in a position to confirm or cancel. Okay? And so with these few patterns, it's easy to see how we can make some pretty sophisticated flows. So service level agreements. This is something that is still a long way to go. Performance guarantees, timeliness, business compensation for failure to perform, quality definitions. The thing I would argue is with the patterns we've talked about in the previous slides around storing messages and when the messages are received and being able to do things, we can actually go back and audit service level agreements. We can put a lot of this together. This is not even nascent. We're just still dreaming about this, I think, in some instances. I mentioned earlier about timeouts as message interaction. So if in a TCP connection, one end goes away, after some timeout value, the other guy finds out that the other end went away as well. So I think timeouts in this context are very interesting, where I'll say, I'll hold, I will automatically process a cancellation for your order if I don't hear back from you in 10 minutes. Again, this happens in real-world applications. It's something we should think about in terms of service applications as well. We say that it's the best that we have today. I actually think it's pretty good if more people thought of these things in terms of invoking cancellations. Okay. Let's talk about wrapping existing applications. Okay. Since existing applications manage resources, they're generally service masters. And how do we tease these things apart? So there's business logic in there, and how can we put a service head on it, if you will? One of the things to do with this is think about what we talked about in terms of reference data, request data, response data, and tentative operations. And how can you take an existing business process around an existing application and sort of break it up or factor it into these steps that we've talked about previously? So many operations are cancelable. Okay? And one thing to think about is I don't have to completely automate the process. So if it's the case that 99% of some tentative operation, if I think about it as a tentative operation, actually confirm, the 1% actually cancel, it's quite reasonable to have that 1% that cancels. The operation inside the service program is to print something out and someone will take it over someone's desk to resolve. Okay? Now, I would argue that thinking about it in this way is a much better way than to say I'm going to try to do a distributed commit and actually hold on to things and wait until things actually either confirm or cancel. The goal, again, is to capture the low-hanging fruit. And how do we take the flow, factor it into these various pieces, and then automate those parts that make sense? Okay? And again, if you can't automate it or you can't automate the compensation, print out a piece of paper and give it to a human to resolve. You'll still be further ahead. And you might wind up with a system that is less brittle than if you try to do it, say, with a transaction itself. So it's great if you can automate the cancellation and confirmation as well. Okay? So again, remembering obligations in the service agent. So this is kind of interesting. So what we can do is use the service agents to represent what we've been obligated to in tentative operations. So in this particular case, we have activity-oriented data that holds the purchase orders. And once we cancel them, so we have a tentative order coming in that generates either an accept order message or a reject order, and then the contract says we'll either confirm or cancel. We can use service agent logic to actually handle some of these things and aid us in the cancellation or compensation. Okay. Let's talk about layering in business processes. So service masters, we talked about before, they're the ones managing the resources. They may well be embedded in legacy applications and wrapping legacy applications, sometimes managed by the service code itself directly. Now, the service master exports contracts, and these contracts, when we do them correctly, support tentative operations with cancel and confirm. Okay, service agents do a lot of the business process. They keep the state of the business process in activity data. We talked about that several times. Okay? And they may have many contracts that they expose. So all of these things are just plumbed together with contracts. And we want to see how we can use this and compose interesting things from them. So they communicate inward with contracts, and service agents communicate with service masters via contracts and messages. So what we can do is build out a business process layer with a number of service agents that may communicate with each other or communicate with service masters and a number of service masters. Now, the beautiful thing about this is it makes it easy to factor this. In fact, I could take some service master that may be doing credit authorizations and actually move it off somewhere else and still retain the same contract. Okay. So let's take this and come up with an analogy between retail and distribution. So hotel reservations, I have a service master that does this. And the contract says that I've got 5 categories of rooms: king size, non-smoking, smoking, doubles, twins. I can do tentative operations and book blocks of rooms with this. Okay? It's an interchangeable resource that's tentatively allocated. Cancellations are easy because of the interchangeability. I can move things around, I can cancel rooms. Putting them into buckets actually makes it easy for me. Okay? Once you have interchangeable resources, you can think of them as commodities. They become what's known as fungible. One is just as good as another. So generally when I go to the hotel, as long as I've got a king size non-smoking, I'm happy. You can pre-allocate interchangeable resources so that any service master can have a supply of them. So imagine then that I want to go, I went to a conference last week, they might have had multiple hotels that were servicing. I would say to them, I want a king size non-smoking room. Didn't really care which hotel I wound up in as long as it was close to the conference center. So the distribution channel can be set up with this. So I can actually have widgets that I push out for efficiency reason, or I can aggregate things. So that's what we're talking about here. Just like physical goods, you can pre-allocate them, you can enqueue them, and you can pass them on to other services and trade on them as well. So In terms of interchangeable resources, okay, we can have someone ready to come and consume them. Come and get my widgets here. I may not be the ultimate widget producer, okay, but how do I advertise the availability of the resources, and why would someone want to get them from me rather than someone else? So a service may issue a demand for some interchangeable resources. He's the local distribution center, and he's going to communicate with some back ends. Hey, I'm looking for some widgets that meet the following criteria. Okay? So then we could have other services. Now, notice how all of this stuff composes. They're all communicating through messaging and contracts. But I can build a matchmaking service. So if there's a distribution service that says, I need widgets, there's a matchmaker that can figure out where those widgets are going to come from. And then I have producers here that are actually producing the widgets and all communicating via contracts to fill up the supply chain. So the trick is to categorize, and how do we actually reason across services, be able to have these matchmakers and others come together. So in terms of conclusion, Eli Whitney was right. Interchangeability is the key. So the key is to make pools of equivalent resources. And this, once we've done this, it allows a marketplace of resources so we can efficiently match supply and demand. We need standards for all of this interchangeable stuff. Okay? De facto standards will emerge by marketplace leadership. We see evidence of this in some places already. Ambiguity, this is kind of an interesting one. Ambiguity increases interchangeability. So specify only what matters. So when I say I want a hotel room, I need it in a particular place for a particular night, and I don't want it to be a dump. I want an exercise facility. I don't necessarily have to go. And there are many cases in many towns where you just call up someone who will find the room for you, and they provide that service. Okay, so I don't have to get up the yellow pages and start calling from the top. Okay, the supply can publish into that, so that's service. I can publish available rooms, and actually there's a lot of services built up today around that. Think about how we could use some of the techniques in here to automate this. Okay, so rambling philosophy. Atomic transactions in the database are singularities. Okay? In the value space of a relational database, things come together, and they go from nothingness to somethingness underneath a transaction. So in a relational database, if I'm going to build an order, I say begin transaction, I insert the order header, I insert the line items, and then once I commit it, it becomes visible. Okay? So that creates a singularity. There's a point before, and the isolation semantics of the database say that there's a before time and there's an after time, and I don't see anything in between. Two-phase commit gives you a singularity, a single point in space, meaning these two things come together and agree at one point in time and space. So it's really hard to spread work across time and space. You have to give or yield on something. For different services, we're going across space. For different messages, we're going across time. So some of the techniques we talked about here, using messaging techniques to avoid distributed transactions, using tentative operations with confirm and cancel semantics for building out more complicated business flows without holding transactions. You can see how those go across space and those go across time. Okay? Reorderability relaxes space and time. So it gives me more flexibility in terms of meeting my commitment. I can give you acceptable answers, and when I show up at the front desk, you can actually assign me a room. Service agents generally don't mind reordering, okay, because they're using read-only data and activity-oriented data. The service masters, those are the guys who have the harder job, because they're managing the inventory, they're managing the actual resources. Compensation is much harder in that space, and that's pretty easy. There are natural examples you can think through in that. Okay, so the implications of Metropolis: heterogeneous happens. Okay, we've got an ongoing IT investment. I think Pat might have talked about the historical monuments that you might have in your system. Standardization is nascent, but I think there's a lot of push for this. We can see the benefits of it at this point. Connection is still largely by people. Efficiencies, we have a lot of efficiencies yet to derive from this. Business processing, again, still mostly nascent and ad hoc, and it will grow, I believe, to become a dominant force. Loose coupling is our friend in this. It helps with our existing investments, okay? And we talked a lot about different techniques for loose coupling, both in the time domain, the space domain, and the data domain throughout this whole talk. Okay? Service-oriented enterprise. Services move us forward, okay? Lots of islands of app code. And I would say you're much better off if you've started off thinking about this from the outset. But when I talked about the two companies at the beginning, the ones who'd gone and built everything as a monolith and the others who'd factored things, the guys who built it as a monolith ultimately realized that for resiliency, for scale, for availability, they needed to factor it. They've gone through that process. It's remarkable to see that their architecture looks a lot like the other one at this point. Independence is essential. Having the contract between us, just like object-oriented programming, lets us separate the implementation from the interface, allowing services to evolve independently. With heterogeneity, with evolution over time, we need this independence, which has implications on the data and how the messages themselves evolve. A question here in terms of what you build versus buy. By having crisp service contracts, it makes it easier for us to make a build versus buy decision in some of these things. Again, this is applicable within your company and across companies. The challenges with respect to security and with respect to understanding the data are a little bit greater across enterprises, but we see this happening already. And Pat, I think, had the same point in his talk, where he was proud of the fact that cleave is a word that is its own self-antonym. It means to pull things apart and to pull them together. So they cleave applications apart into independent pieces. And you can cleave things together, meaning that you can compose things from services. We showed lots of examples of both of those throughout the entire talk. Okay? So building services now. Microsoft has realized this and is investing a lot in services. From Indigo, from features within Yukon, for managing XML, for the service broker for doing the reliable messaging out of Yukon. You can build services now. It's going to get easier in the future. Every pattern that I showed here today is something you can go out and build on your own right now. In fact, the existence proof was that company I talked about way in the beginning, who had built this out 3 to 5 years ago. And so you can go off and do it today. It'll get easier in the future. So that about concludes it. I made it through 98 slides in just a little less than an hour and a half. We have a couple minutes for questions. So for those of you who have to run, that's fine. I appreciate your time, and we can open up for questions. Yes?
If I have one environment using two-phase commit and I have another environment that's not using two-phase commit, what are the complexities?
Okay, so you have an environment that's using two-phase commit and an environment that's not. So
I do withdrawal from one bank and a deposit in a different bank, and one of them's using two-phase commit, one of them's not.
So I mean, two-phase commit fits in various places quite well. When things are very close, and there are many definitions to close, administratively close, physically close, by connectivity close, two-phase commit works very well. So in terms of managing message data, if you're using an external message queue, it's quite natural to be able to dequeue the message within a transaction, enqueue the work within the database, and do two-phase commit across that. It gets harder when you're in larger space and time, and you'd have to figure out a way to be able to communicate with the other guy to be able to do the two-phase commit. I don't know if you have anything to add to that, Pat.
No, you're doing great.
Okay. I guess the challenge would be if you actually had some that did a two-phase commit and other service masters, if you will, that didn't, and you'd have to come up with something then to bridge the two. Yeah. So I don't have any pearls of wisdom for that one.
Okay.
Do you?
No, I mean, it's just, to me, if you're using two-phase commit, then the two of them become like one service. Right, and so that's kind of the model. I mean, these guys are intimate, It's kind of like they don't have good hygiene, and so you're kind of in this pool of, not having.
Leaving
and
the
so
hot
now
tub
the
together?
question is, how do you then have a service interaction across them where they don't share?
Okay. Any other questions?
Would we knocked you into a stupor? Are you out for the day or what?
There's one.
There's one.
Could you discuss the sort of the REST approach, where the message is the state rather than the database is the state, and your experience of using that approach?
I am not an expert in the REST. I mean, I've read some of the great debate. I don't know if you have anything to add.
Well, it seems unencapsulated to me, is my visceral reaction, right? Because, one of the things we're preaching is you're going through the business logic. So my example, you go up to the ATM, can you get an ODBC connection? Well, probably not. And so I actually tend to think that isn't such a good thing to do that. Do you understand what I'm saying?
Yeah, I'm worried about the scalability of the message sizes. I mean, to me, it must grow if you're holding that state of the conversation in the message.
Yeah.
It
Well,
must
that doesn't worry
explode.
me. That doesn't worry me at all, just like the XML bloat doesn't worry me at all, right? Moore's Law is doing great, networking is doing great. I worry much more about pounding on shared resources and how to pull apart access and competition for shared resources. But again, I do worry about encapsulation, not trusting the other guy, right? And so I want to mitigate via business logic. So that's my biggest fear, is that semantic. I tend to think of it as CRUD, create, read, update, delete, and the fact that, and where it gets funny is, every noun can be verbed, right? And people will they'll use data operations to really mean call this code, and they'll use sets and gets to really mean data operations. Do you see what I'm driving at? And so it's much more about the semantics of the operation and pulling them up to a business-oriented thing and pulling them away from an artifact against the storage thing. Am I addressing your question?
You are. I mean, while I've got the microphone, if I can ask another question, what's your experience of trying to change the mindset of people away from RPC to services? I mean, that's one of the things I'm struggling with.
I mean, I've been around long enough. I still remember fighting that, a C-level, high-level language was an acceptable thing to write a database in, a database management system in. And so natural selection will just take care of it. It's not a problem, right? You just keep chugging away. They get old, they retire, they learn, it's okay. Well, no, wait, this is going to take time, For crimity's sake, we're sitting here and we're talking, at our PDC about a Longhorn release. Well, when's that going to be? Well, not in 2003, right? And that's the foundational plumbing for this. This is going to take time. Now, but again, both of these two talks ended with do it now, because the more you start thinking about being in pieces, the farther ahead you're going to be, even if the plumbing gets redone, even if the ways you hook it together gets redone. Am I answering your question or not? So
you're answering a very interesting question.
Well, but the mind share, it just gradually changes, and no one remembers that crisp moment when they became a believer, right? I was out doing distributed objects. Like I told you, it's as much my fault as anyone else's. Then I had this epiphany that messages are asynchronous, and life moves on, right?
So I think it's interesting when you start thinking about evolution and decoupling, right? Where's the center of gravity? Or where does it all start? If the message, it makes it much easier, both in terms of evolution, some of the concepts we've talked about, and the implementation, having heterogeneous implementations that could evolve independently. The other thing that I go back to your REST question would be, if the state is flowing around with the message, I think that's fine for request response, but as we get into some of these patterns that have tentative operations, and we talked about the activity data, which could sort of flow around with it, being private. Right? That's
exactly.
Something that,
I'm managing the hotel reservations. You promised to do this. I've got, a king-size non-smoking room earmarked for you, right? Well, what's going to happen if you don't get back to me? You're not sending all the darn state around in the message, because I got to know what I got to do.
Yeah.
One of the examples, I'm a travel agent. It is service agent stuff. There's only information about your trip associated with this bundle of crud. Well, your check bounces, right? I'm in deep trouble if I don't go back to all these airlines and tell them, okay, we're canceling this thing. So yes, it's actually a lot easier to code that service agent thing, but I can't just bundle it up in a message and let it go squirting around into untrusted worlds, right? To me, that's not looking at the reality of autonomy. That's what I'm trying to point out, is it's about autonomy and what I got to know to cover my butt in my service. Am I helping with that?
I think that's a much better answer than the first one.
I actually said it, but I didn't say it that clearly. Right? I've got one over here.
Yeah, in fact, I have two. The first is okay. Thank you. The first is about business logic in objects. What we hear now from Yukon Technologies are hosting the common language runtime, writing store procedure in C#, exposing store procedures as web
that's
services.
his fault. Okay, he's
and
doing that.
all this seems to make disappear this border between objects, business logic, and the database.
No, it doesn't. Okay, keep going.
Okay, that means, you may still say, okay, this business logic level is now existing in the database, is being hosting there, but then you have all the problems relating to scalability and so on, because the database is much more unique than instances of service.
Okay, so let me address that one first. So our design goal was to make it a deployment decision, whether I could run the logic inside the database or out in the mid-tier. Okay, so
sometimes it's more efficient in, and sometimes it's more efficient out.
So when you bring it in, latencies effectively go to zero. okay, meaning that I don't have the network latencies, I don't have things operate in one way there. So I want to run it in as long as I've got the bandwidth and the CPU bandwidth, because I get efficiencies from not having the latency. But as soon as I push it out, then I can scale it, right, and actually run the compute cycles out there. And what we try to do, again, is make that a deployment time decision rather than a design time decision.
Sometimes running it out is less efficient. If this thing is really going through tons and tons of data, the fact that it's closely tied to the data means it's just going to take, it's going to hit the database less than it would if the database has to put it into the TDS thing and send it TDS back and forth, you know. So sometimes deploying it in is actually less consumptive of CPU cycles on that database engine. Now, if you do one record read and then you compute for 3 months, right, that's much better to run it outboard. So that's the advantages of having the deployment choice based upon the app code and the component. Did that help? So second question?
Yeah, the second question is about, we had a lot of support in Microsoft technologies for transactions, starting with DTS, Compress, attributes in .NET. Can we expect the same kind of support now for cancellation, confirmation, compensation? Because up to now, all the high-level talks are talking about this, but there is no type of support in the tools and languages.
You want me to do it?
Yeah, you take that.
So the reality is, we don't know how to do that generally yet. That's just the reality. So let's talk about evolution. You know, people build stuff in applications, and then platform guys look at it and say, you know, I can generalize that. And then they push it into the platform, and then the apps evolve to use the generalization, right? And then the apps add more semantics, right? And then the platform guys look up, and the platform keeps rising higher and higher and higher. I mean, operating systems kind of weren't there back in the day, right? And, you know, and those abstractions rise and rise and rise. This talk here is trying to say there is a generality, right? There is a pattern, but we don't understand it as a community well enough to formalize it into product. But that doesn't mean you can't take it and run with it as you build your apps. There's that period of time when we're still learning, and you can still use it, and it's very useful.